Please and thank you. Using the range, the mean, the standard deviation, these are all good indicators that help us make decisions and analyze, right? Used to analyze data, right? So you would have hopefully typed all of these in this one probably into L1, right? I would have gone L1, L2, L3, and so forth. Okay, and then we came up with the range, all of that. I will just quickly give you what that is. This would have been 18, 5. So the range is just subtracting the highest and the lowest values. Okay, so we come up with that. You probably would have done one row at a time. But right here, we can tell just by looking at that Morgan has the greatest difference between the highest and the lowest score, right? If you were to put all these players on a number line, for Morgan, it would be definitely, right? The gap would be significant between the low, right? Between the low and the high. So that's what the range tells us, what that gap is going to be. And all the other points are found between those two, right? You would agree. It's Monday morning, so you got to kind of wake up on that. But that's what's happening. Versus page, if you just look at page, it's probably like this, right? This is low, this is high. Like we know that all of her other scores have to be lying between this tiny gap, right? However, what we don't know is just, morning. Along the number line, overall, on average, is Morgan still doing better than Paige, right? Because right now, when we just look at the range, we just know what the gap is between the highest and the lowest score, right? That's what we know. Because let me just get a piece of scrap here. It could be that if we had our number line, right? It could be that Morgan is inconsistent, but it's somewhere up here, right? And it could be that Paige is consistent, but Paige is somewhere below on. It's still scoring less than Morgan, right? And this is Paige. So that's what we know. What's the difference? It could very well be that Paige is somewhere in here, right? And you looked at the numbers and figured that out most likely. But just looking at the range, that's what we know, the difference between the high and the low. You most definitely would expect that the range, a bigger range for Morgan would also mean a bigger standard deviation. That is most likely going to be the case. You should see a correlation between that, right? And so let's figure out the mean for all of them. This was 36.7, 36.4, 35.8, 33.9, and 36.3. So this is just overall, on average, who scored the most. And we look at the numbers, and we would have to say that Anna wins this one, right? Anna, on average, scores the highest, but has a fairly high range. So it's not very consistent. Has some good days, some not so good days, right? And let's look at the standard deviation. This would have been 5.88. This would have been 1.50. This is 9.02, 0.83, and 3.35. So I have a spreadsheet, right? I just plug in some numbers to make the point here, right? And right off the bat, you would have to say that Paige has the lowest range and has the lowest standard deviation, which is what we would expect. What does that tell us? Consistency. Paige is consistent. Scores doesn't do so well overall, but Paige is consistent, right? And as a coach in sports, consistency is very important because you can work with that player and just raise that level, right? Like you can work on things and just that player will deliver almost consistently. You just have to work on some skills to bring that player up to a different level, right? Who's next up, right? We would have to say Patrice, right? also has a fairly low range and a fairly low standard deviation. And if you look at the average, score is higher, right? So if you were a coach and you're looking at this, you're like, you know what, Patrice is probably one of my better players because average is fairly high, standard deviation is fairly low. That's a good combo. That's a good combo. You might say, well, Anna's still a little bit better. Yes, but inconsistent, a lot more inconsistent than Patrice because of the high range and the high range and the high standard deviation. Low range, low standard deviation. So I'm kind of mixing everything up here, what you should be looking at. So let's answer these, and you most likely will have already. If not, then here we go. And it will probably differ a little bit from the key. I'm telling you right off the bat. But which player would be considered most consistent? Which player is least consistent? Explain how you know. So most consistent would be Paige. Paige, comma, since her range and standard deviation is low or are low, right? They're both low. It tells us there is more consistency, right? And I would expect you to use these words, right? I want you to use statistic terms to make that conclusion. Don't just say I think it's Paige. Well, why? Well, her points are pretty close together. Still, you got to keep going, right? The range and standard deviation is what we're talking about. Let me make a further point to this. Range shows us how far away the highest and the lowest point are. Standard deviation looks at every single point and finds the average distance of every single point to the average. All right, guys? So range is just looking at 2 points, the highest and the lowest. Standard deviation looks at every single point and finds the average distance of every single point to the mean. All right? So let's say you find the average 36.4. The average distance of every single score for Patrice is 1.5 points. So it's not too bad, right? Like all points are very close to that average. Every single point is on average close to the mean. Versus, am I getting too excited? I gotta calm down, right? Versus Morgan, 35.8 is your average, but the points are all over the place. On average, that distance, so it tells you a spread, right? It's spread out, okay? So let's see, least consistent would be Morgan, okay? Morgan, since her range and standard deviation is highest, I would say, right? Okay, and this goes right back to closer to the beginning. We're going to look at that in a little bit. I'll make my point even stronger. Next, B, identify the player with the greatest average score. Would you consider her the best player? Explain. So the greatest average score would be Anna, right? What did I write in my key here? Oh, maybe I deviated a little bit, right? Yeah, I see that the key is a little off. That's why you were torn. I get it now. Identify the player with the greatest average score. Would you consider her the best player? So Anna has the highest average, has the highest mean score, right? Which tells us that on average, she does better than the rest. But what makes, I don't know, basketball, right? What makes a basketball a great player is not just scoring great in some games. It's like you consistently want that player to be good, right? You're like, you know what, LeBron James. Sorry, I'm not a basketball. LeBron James or whatever, man. Like every time, right? Or what are some other names in basketball? The Curry. That yeah, I like Curry, so that's why I know the name. Rings a bell. But right, they're consistent. Right, their free throws are pretty consistent, and you can almost bank on them making a difference in the game. Right. Uh, sure, they have their bad days, of course, bad games, but you want that consistency, right? On average, just better than the rest. I would say this, I would not consider her the best player, comma, since her standard deviation, we're just going to go SD for now, just to save some space there, is a little high, right? You can talk about the standard deviation not as consistent. And of course, we're comparing here, so that's in comparison to others. Which player has the potential to score the least amount of points at any given game? Which player has the potential to score the most points on any given game? Okay, so we can say potential for least, right? You would say, in my notes I have that, but I'm just gonna scan here. My guess is Morgan, right? 19. Is that the lowest score overall? I think so. I'm looking at my key here. Yeah, I actually showed the work for range. I'm just going to the range and I'm looking for the lowest value I see, and that's 19, right? Morgan, right? Since her lowest score is 19, right? And the highest, is that Morgan as well? I'm looking 48. 48 is Morgan as well. Potential for most scores would be Morgan as well. Since she scored 48 at one point. She scored 48 points, I should say, right? In a game. So there we have that. So Morgan, I explained it. This is, I will say, something along the lines. Morgan has both extremes. Which is reflected in her high standard deviation and range, right? I'm just going to talk about standard deviation here. Sorry about that. It's kind of blurry, eh? Okay. Morgan has both extremes, which is reflected in her high standard deviation. You can also say in her range as well. Both would be accurate to say that. Okay. If you were a coach, which player would you choose based on your decisions on what you know about the standard deviation? Right? As a coach, this is what I'm going to say here. As a coach, comma, you would want to look at a player with a relative high mean and a low standard deviation, right? And that, why is that? You want that consistency. So you would want a relative high mean with a relative low standard deviation. You want that combo, right? So is it going to necessarily be the player with the highest score on average? Nope, wouldn't be, right? Would it be the player that scores potentially the highest, which Morgan would have been? Nope, not necessarily, right? And Morgan is also potentially, yeah, she has the potential to score the lowest. So I don't know if you want that, right? So who would you pick? And the answer in this case, the best combo would be Patrice, right? Patrice has, just be creative here, has the second highest average, right? And the second lowest standard deviation. So I will just make a mean is 36.4, standard deviation is 1.5, right? She would be a good pick. And if some of you picked Anna instead, because Anna has the highest average, you could say that as long as you justify, I would pick Anna with 36.7 average, right, points on average, even though she has a slightly high standard deviation. Okay. Oh wait, did some of you say star perhaps? Right, star, which let's go back up to this. As long as you justify, questions like these are like, do you know what you're looking at as a coach? Are you able to justify, right? So star could also be a good pick because the average is just 0.1 less, right? And her standard deviation is also fair. It's lower than Anna. So maybe you want to pick star, right? Star has the third, so this would be the lowest, second lowest, third lowest, right? Standard deviation. So you might want to pick star. That's fine too. I would accept that, right? Because her average is, she's third on average, third lowest standard deviation. It's also a pretty good pick, right? I think if you picked Morgan, you would be out of, that would not score you marks, right? Paige, you know what, Paige, you probably would have a point there. You're like, even though she might be a rookie, she might have just started, low, scores low, but is very consistent. So as a coach, I would be able to work with that player and just bring up, right? Maybe do more reps, do more of everything, and just bring the average up. I would take that too. So just read the question carefully and justify accordingly. Okay. All right. Okay. That is page 9. That is that makes your head spin, right? Let's go to the battery. I want to make sure you have the battery question figured out as well. Did I finish the battery question? Did I do that in class with you? Or did I think I assigned that, right? So why don't we just quickly look at what is happening here? Because I would expect you to be able to answer this kind of stuff. So you put all the lifespans of brand X in L1. This goes in L2, right? That's what I would do. L1. This is on page 7, in case you're wondering. So we go back in time here. L1, L2. Right away, right? 5 times 6, that's 30, right? N would be 30 here. That's something I would like you to, because when you're entering that many points, if you're rushing, there's a chance that you will A, miss one, B, there's decimals. So it could be that you type in 61 instead of 6.1. So you got to watch out, you got to take your time and not rush on this one. So here's the key. Obviously, I would do one at a time. So why don't we do brand X first? And you can just look and make sure you match, right? The median is 5.75 years. Standard deviation 1.22 years, which right now you're like, hey, that's a pretty low. It's off by like on average, we're about a year away from our average. But let's see how that compares to the other brand, right? The range 8.2 minus 3.1. I like to see these numbers in general. Like, what are you subtracting? Because it also may help you to make your description later on. And the mode would be 5.7 years in this case because it shows up 3 times. And I'm going to write down n is equal to 30, right? So use your calculator to do that. Same with brand Y. Mean is 5.72 years, so you notice it's slightly less. Let's see, let's continue. My median is exactly the same. And I will ask you this all the time. What does the median tell us? I don't want you to just know it as a number. What does it tell us? It tells us that half of the batteries last longer than this. Half of the batteries will last fewer years than this, right? So keep that in mind. Standard deviation. So today I will be talking a lot, just making sure it sinks in right before I continue. Oh, wait a minute. There's a big difference there. It's half, right? Half, about half. And the range is 2.5 years. I would expect you to know how to do all this using your calculator, right? One variable stats. All of this can be done using your calculator. And the mode is 5.9 years. Again, I have 30 values here. Could be that one company has more data than others. In this case, they both have 30. Okay. I will just at the top here, I went one variable stats, and I typed in L1, one variable stats. I typed in L2, right? Just to make sure you understand that. The number line or line plot, I would expect you to do that on your own. I will show you what it looks like. So here it is. Not yet. Snap your fingers, boom, there it is. Don't quit your day job, right? So brand X and Y, you may have used a different scale. That is fine. You may have used a scale of 1. I don't know why I went all the way to 13. Don't ask me. I just started something there. But you can tell, you should be able to tell that brand X is a little bit more spread out than your brand Y. They're clustered, right? Wouldn't you say so, right? Spread out, clustered. You should be able to see that. Line plots are great at that. And that confirms our theory, right? Brand Y, watch this. Now, where's my standard deviation? I'm just going to write it down here. My mean was 5 point. I'm just going to peek 1 second. 7.4. I'm just going to write it down because I like to see it there. 1.22 years. And this I just box in. And I'm just doing that because we're describing it. It's not necessarily a requirement for line plots, right? And for this brand, we had 5.72 years. And my standard deviation was 0.64 years. Remember, the unit should always be there, okay? we expected the standard deviation to be lower for this set, right? We expected it because it's clustered, okay? I'm saying this about y, right? Clustered around the mean, right? How do you know this? Low standard deviation, right? So the standard deviation tells us that it's clustered, and the graph confirms it, right? The graph confirms it. I'm saying that a little note here, the MCTs, the mean, median, mode, they're all fairly similar. Like if you label it, they're all close together, right? Which is a good thing. That is actually a good thing if they're all kind of lining up. Okay. Which brand would you pick? You know what? Everything else aside, you would pick brand Y because it is more consistent. You're going to get what you, and the average is about the same. The average is almost, that difference is negligible. You're going to probably get, like if you buy batteries consistently from brand Y, right? You're going to get what you pay for. They claim 5 years, 5.7 years lifetime. It's going to be more likely to be the case. Here, it's going to be off a bit more. It could be over or under, okay? You might say, well, I'm looking at price, Mr. Dirksen. I don't just look at the standard deviation. True, that is some of the considerations you would take, right? What is the warranty? What is the price? Stuff like that, but that's besides the point here. I do make a note for X, spread out further from the mean. That's just my note, and I would say high standard deviation, right? High standard deviation confirms that, right? Or like it all goes hand in hand. High standard deviation tells us that it's going to be spread out on average. Most of the points are going to be further from the mean, which is confirmed by the graph. And you might say, but it's not significant. It's still they're pretty close together. Yes, but these ones are closer together. Okay. Yep, right? I just want to sleep. I get it. Did I post this key? I'm not sure. I may have. So let's talk about describing. Describe this data using the mean, range, and standard deviation. It's the same thing as what we just did, basically. Okay. So how about I will just tell you what it is, and you make some notes maybe if you didn't get to this. Okay. But brand X has a slightly greater mean, therefore slightly greater lifespan. It has a greater range. Lifespans vary more than brand Y. It has a greater standard deviation. Lifespans are more inconsistent, right? Since the standard deviation is greater. So that's coming from brand X perspective, and I would be fine with that. If you come from brand Y's perspective, slightly lower mean, which is a slightly lower lifespan, that's what it tells us. Smaller range, lifespans are closer to the mean. Smaller standard deviation, lifespans are more consistent. There's that word, perhaps the word of the day is the standard deviation and consistency, right? More consistent. Why is that? Because of the smaller standard deviation. Smaller standard deviation, more consistent. Which brand would you recommend? I'll leave this up for a bit. You write down as much as you need before. Okay. Talked a lot. If you go to page 10, every once in a while just leave a blank there just for scribble and notes and like maybe like what do we know so far, right? And let's just talk about standard deviation, right? Gives us the average distance of every, this is on page 10, every point to the mean. Isn't the mean the average? Yes. But mean is the actual, considering every single point, we find an average. Standard deviation is the average distance of every single point to the mean. So if you have a number line, right, and let's say on this number line, let's say your mean is there. Standard deviation would do this, okay? You plot your points. Right? You plot your points, right? So let's say we have 4 points there that we plotted on our line plot. It would figure out, okay, what's the distance from this point to the mean? What's the distance from this point to the mean? What's the distance from this point to the mean? And so forth, right? It would take all the distances and just give you the average, okay? Considers, right? Considers all distances. Considers all the distances to the mean. Okay, this is just an example, right? Another example. And this is just scribble, so don't make it look pretty, right? But I like pretty. That's okay. Right now, we just want to talk about concepts, right? It could be that you have your number line, and for some reason you're comparing another brand, another product, what have you. Maybe the lates in a class, I don't care. But you end up with your mean being here. It could be, you know, that your points are all like you even stack them because you have doubles, right? This would have a low standard deviation, right? Since the distances of all points is low, right? So it considers the averages, right? So the mean could be anywhere on that line. It could be anywhere, okay? But the standard deviation tells us how clustered. So this would definitely be a key word here, clustered data, right? This would be spread, right? Spread out data. That's just scribble there. We can come back to it and add more to it later. Okay, let's keep going. I want you to, for homework, and these are brand new questions that I just inserted to the book. So I want you to try 11 and 12, pages 11 and 12, but I will add to it because as is, you may not know what you're supposed to do. Okay, so put homework in there at the top of page 11. Okay. You're with me, right? Because I'm going to add, maybe even take away stuff. Because I just like the data points and the fact that you're comparing. That's what I liked about these questions. So you can scratch the C, for example, just the modes. Were they useful to compare the situation? We don't use modes. Like the mode, I want you to know how to find the mode, but we don't really use that to compare. Okay, so I will say rather than you doing that is calculate, this is on page 11, the mean, range, and standard deviation for both sets. Okay, that's what I want you to do there. So figure out that for both classes, and then make a bit of a description. What do you observe? Is one class on average doing better, but has a big standard deviation, which tells you, wait a minute, there's inconsistency there. You might have as few students scoring 100% and other students not doing well at all. That is generally not what you want, right? Make an observation on that, okay? Let's keep going to page 12. Page 12, you go homework as well. Pardon those check marks. I couldn't quite erase, like I was doing some pencil work on that, and I couldn't erase that when I scanned it, but that's okay. So again, we're comparing the housing prices for 3 different time slots. It's a bit dated, I know, but that's besides the point. Why might a comparison of these be useful? All I want you to do there is calculate the mean, actually just the mean and standard deviation to describe data. And I will guide you on that. Like if I will post a key and then you can look at it, it's like, does my answer kind of jive with Mr. Dirkson's, right? What are some observations you make? And I would expect you to be able to do that. No line plots, nothing here. We're just looking at these numbers in particular, the mean and the standard deviation, because we know that the standard deviation tells us how clustered or spread out it is. And we know that if we compare between others, that a low standard deviation means more consistency, right? Okay. So 11 and 12 shouldn't take you that long, but it's good practice, okay? Let me skip 13 and 14 are important, but I'm going to skip that for now. I asked you to, I'm going to stop this video here and start a new one.